Guys, today we're going to be looking at two types of geometric proofs. These are two types that we've looked at before. So this is taking segment addition and angle addition and mixing it with the algebraic proofs that we covered this week. So let's not forget all of the properties that we've learned so far. So addition, subtraction, multiplication, division, these are all ones that we've done numerous times. The other ones that we're going to be looking at a lot today are both substitution and symmetric. So just as a reminder for substitution, if x equals a, or let's say x equals 2, then 2x is going to equal 4 because we're going to substitute 2 in for x. So that's going to be a huge one that we're going to talk about today, as well as symmetric property, which says if x equals a, then a equals x. So those are two big ones we're also going to be looking at today. Just as a reminder, segment addition. So suppose you have a segment A, B, and C. They all sit on the line or are collinear. And B is between A and C. Then we would say AB plus BC equals AC. So we talked about this briefly. It's the idea of the two smaller segments equal the larger segment. For angle addition, it's very similar. Suppose we have these two smaller angles, ABD and DBC. Okay, so we have angle ABD and DBC. All right. We would say if we add both of those angles together that we get our larger angle, which is angle ABC. Okay, so the idea of two smaller ones equaling one larger one. All right. Now, substitution and symmetric, I had explained that earlier, that these are two that we're going to be looking at. Just to review what those are. If AB equals BC and AB plus BC equals AC, then what we're going to do is, instead of AB, I'm going to put BC. So it's going to be BC plus BC equals AC. Okay, and then I could easily solve from there. That's what substitution is talking about. Symmetric property, that's just to review. I had said that earlier. If x equals a, then a equals x. So it doesn't matter which order you put those in. They're going to be the same no matter what. Now let's look at some examples. So we have our given information that AB is 12 and BC is 5. So we need to prove that AC is 17. Now looking at this, it's pretty easy to see that it's 17, but we want to go through a two-column proof. So the first reason AB is 12 and BC is 5, our first reason is always going to be given. All right. The next reason, notice that it says AB, so this smaller piece, plus BC, which is this other piece, is equal to AC, which is the entire piece. So that again is AB plus BC equals AC. Well, the reason for this is segment addition postulate. And you can shorten that if you want, just like segment add postulate, that's fine. All right. Then if you look at this one, AB has changed from 12 and BC has changed from 5. Well, if you look at statement 1, it told you that AB was 12 and BC was 5. So this is known as substitution. All right. For step 4, you'll notice that they added 12 and 15 to get 17. So this is simplify or combining like terms. And then for the last step, you'll just notice that they switched 17 and AC. So this is going to be symmetric. So our given is always first, then segment addition. Then we're going to be substituting what lengths we know, simplifying by adding 12 and 15, and then symmetric with putting AC on the left-hand side. Let's look at one more example. So if you notice with this one, we have a little bit of more algebra. So it says given CD equals x minus 1, DE equals x plus 5, and C equals 10, prove that x equals 3. So our first reason is always going to be given, and we're always going to put our given information up there. So the CD equals x minus 1, D equals x plus 5, and C equals 10 we put in here. Now here it says CD plus DE equals CE. So I'm going to go up to my drawing. You'll notice CD plus DE equals CE. So this is also going to be segment addition. All right. The next step, you'll notice that we took our given information. So instead of CD, we put x minus 1. Instead of DE, we're going to put x plus 5. Instead of CE, we're going to put 10. So we're replacing values or doing substitution. Okay. The next step, you'll notice that we combined like terms. So another way that we can say this is to simplify. We then subtracted 4 from both sides, so this is going to be subtraction property. And our last step was that we divided by 2 on both sides, so division property. So we took our given information. We know that we're dealing with a segment here, so we're going to introduce our segment addition postulate. We substituted all the values that we have for the segment, and then we solved. So combining like terms or simplifying, subtracting 4 or doing subtraction property, dividing by 2 or division property. So what I'd like you to do is take the next 5 minutes and go ahead and attempt this next problem on your own. We'll be going over it in 5 minutes. So 5 minutes on the clock. Go ahead and get started. If you're really stuck, the second reason is going to be segment addition. And the third reason is going to be substitution. Just over 2 minutes left. Remember that your first step is going to be to list all your given information. Just over 1 minute left. About 30 seconds left. All right, so the hints that I gave you were that the reasons were segment addition and substitution for 2 and 3, and that you should always list your given information first. So for segment addition, if I'm looking at my segment here, my two smaller pieces are JK and KL. So JK plus KL. And that's going to equal my larger piece, which is JL. I then said we're going to do substitution. So if I'm looking off to the side here, JK is equivalent to X, and KL is equal to 2X minus 9, and JL is equal to 9. I then have some like terms to combine for number 3. So it's going to be 3x minus 9 equals 9. So this is combining like terms, or simplify as we have come to know it in our 2-column proofs. We're then going to add 9 to both sides, so we get 3x equals 18, and that's through addition property. And lastly, we're going to divide by 3 on both sides to get 6, which is division property. So we had our given information, our segment addition, which is JK plus KL equals JL. We then substituted all our values, so JK is equivalent to X, KL is equivalent to 2X minus 9, and JL is equal to 9. We then had like terms to combine or simplify. We then added 9, divided by 3, and that gave us our final answer. Now, you can also use these same exact things for angle addition. So let's look at 2 angle addition ones. So the first one is, it says given angle ABC is 30 and CDB is 40. So I'm going to mark up my diagram immediately. So ABC is 30, CBD is 40. Prove that ABD, which is the large one, is 70. So we can pretty much figure out pretty easily that it's 70 when we just add the values, but let's look at this in a 2-column proof. So our first reason is always given. All right. And then our second reason for most of these is if we have angle ABC and CBD, which is our 2 smaller ones, and it equals our larger one, this is now going to, instead of segment addition, is going to be angle addition postulate. And then the same things are kind of true following that. Notice that we substituted our given information, so ABC is 30, CBD is 40. So this is going to be substitution. And then we added them together or combined like terms to give you simplify. And then notice we just switched 70 and ABD. So this is going to be symmetric. So angle addition is almost identical to segment addition. It's just we're looking at angles, and our reason is angle addition postulate as opposed to substitution. So let's look at one more example using a little bit more algebra. Okay, it says given TSZ is x plus 26. So I'm going to mark mine up immediately. It just helps me. All right. ZSR is x plus 32. So that's this one here. And then your large one is 146. So I usually just do this, 146. Prove that x equals -6. Well, our first reason, if you look, is always going to be given, because it's our given information. And then if you look at number 2, it said angle TSZ and angle ZSR. So those are our 2 smaller ones equal TSR, which is our large one. So this is going to be angle addition postulate. And then the rest of them are going to kind of follow suit. Number 3 is obviously going to be substitution, because we're substituting all of our values from the given information. And then it's just algebra from there. So we have like terms to combine. So that's going to be simplify. And then we subtracted 158 from both sides. So that's going to be subtraction property. And then we divided by 2 on both sides. So that's going to be division property. So we took our given information. We noticed that we had, for number 2, was our angle addition property, postulate, where we added the 2 smaller to get our larger. We then substituted everything in, so x plus 26 for the first angle, x plus 32 for the second angle. We then had like terms to combine. We subtracted 158, so that's subtraction property, and then divided by 2 for division. So our last problem for today, I'm going to put 5 minutes up on the clock again. And it's the same thing as the previous one. I've given you 2 of the smaller angles and 1 of the larger one. So I would mark up my diagram first, put all my given information. All right. 1 minute has gone by. If you haven't done so already, I would go ahead and mark up your diagram. So this one is 4x plus 8, and this is 20x minus 5, and the large one altogether is 171. Remember, your first reason is also always going to be given. Half the time is gone. If you're still stuck, your second reason is going to be angle addition. Your third reason is going to be substitution. If you're still really stuck, go ahead and put your given information in. So just over a minute left. Go ahead if you can see if you can figure out the rest of it. Just under a minute left. All right. So what you should have had for number 2 was your angle addition. So saying angle PQF plus angle FQR is equal to angle PQR. So that's saying that the two smaller angles are equivalent to the larger one, which is PQR. I then also gave you the hint that number 3 was substitution. So for PQF, that's 4x plus 8 plus FQR, which is 20x minus 5. So let's make my 5 look more like a 5. And that's going to equal 171. All right. Similar to the last ones, we also have substitution. So I'm sorry, simplification, because we do have like terms to combine. So we get 24x plus 3 equals 171. And our reason is because we combined like terms or we just simplified. We're then going to take away 3 from both sides. So we get 168. So 24x equals 168 by subtraction property. And then lastly, we divided by 24. So we get x equals 7, which is our last one. So this is our division property. So those again were angle addition, substitution, and once you put all those values in for substitution, you get 24x plus 3 equals 171 once you simplify. Subtract 3, so subtraction property, and divide by 24 to get x equals 7. You'll notice on Edmodo there is a practice for you guys to work on that gives you more opportunities to have this, but it's pretty straightforward once you know what the given angle addition or segment addition and substitution property are.